Good morning and good afternoon, everyone. It's great to have so many participants here today for this section number 6, our 5th webinar in our series Step by Step, the Higg FEM Verification Trail. And today our topic is the air emission section. My name is Karin Ekberg and I'm the CEO of Leadership and Sustainability. I have more than 35 years of work experience, always in the sustainability area. And I have been responsible for environment globally at adidas, but I have also had other senior roles managing sustainability at other corporations. And now, since more than 5 years, we are underway with leadership and sustainability, serving the industries in terms of improving the sustainability performance. And just a brief recap about the GoToWebinar features. You are on mute today so that we have a good audio quality. You can send your questions throughout this webinar to us, and we will have time towards the end of the webinar to take your questions. And rest assured, you will receive this recording and you will receive the presentation as well after this webinar. So within 1 or 2 days after this webinar, you will receive all the documentation. So don't worry about that. And a brief call out that these materials are copyrighted. And now to the agenda. So a very brief introduction about the verification trail and its purpose, and then we will dive into the section number 6, the air emission section. We will have time for your questions and a discussion as well, and we will also give you some information about our services and about our company. The verification trail and its purpose is here for you to get a better understanding of the Higg index and, of course, in particular, the Higg FEM. We guide you through all sections and all questions one by one. We wish you to get acquainted also with the requirements. So this is not only about completing the self-assessment, you actually also should make sure that you fulfill the different requirements in the related questions and that you upload the correct documents, etc. And of course, this is about improving performance. We really would like to see that we all have a much smaller environmental footprint moving forward. And finally, these webinars also can help you to prepare for your verification if you are intending to go through a verification. And here is the overview of all sections in the Higg FEM. And you can see we have here the section number 6, air emissions, our topic for today. Managing air emissions requires a different approach than managing energy, water, and waste. Air emissions are regulated to a set level, while the impact of energy, water, and waste can be continuously improved by reducing quantities. So we differentiate for different types of emissions, and this is important for the entire air emission section to know this differentiation. We have point source or stack emissions. Those are stationary identifiable sources of emissions that release pollutants into the atmosphere. Examples include emissions from boilers and other combustion facilities. Then we have mobile emissions, emissions from equipment that moves from one location to another. Examples include motor vehicles and construction equipment. And finally, we have the non-point or fugitive emissions, emissions which do not pass through a stack, a chimney, a vent, or other functionally equivalent opening. Common sources of fugitive emissions include screen printing, foil printing, molding, etc. Fugitive emissions could also be the result of construction activities that generate dust or other emissions. These types of emissions are seldom included in the permitting process. And so for the applicability, as you know, in every section, we have applicability questions at the very beginning, very important questions in order for you to later in that section receive the correct questions. So you need to ensure that you have the correct applicabilities. And first of all, we are differentiating between operations equipment like generators, boilers, ovens, air conditioning, etc. And then we have the processes and the substances, printing, drying, dyeing, etc. And then the question here, also already in the applicability section, is are you monitoring your air emissions? And we differentiate between indoor and outdoor emissions. Indoor emissions may come from printing, adhesive processes, if you are a footwear factory, for example, spot cleaning, where you perhaps are using volatile organic carbons to use as a spot cleaner. And then we have the outdoor emission, like for fuel consumption, spinning, dyeing, etc. And I have here a few examples for you of different pollutants that you may have in your air emissions. So depending on the process, like for energy production, you have the emissions from boilers. You may have particulate matters, PM, nitrous oxide, NOx, sulfur dioxide, SO2, and the concentration or the volumes of those pollutants may differ very much on the type of energy source that you have. If you are using coal, diesel, or oil, or natural gas, this will influence it strongly. And then we may have, for example, coating, drying, and curing processes, where you may have, for example, volatile organic compounds as the pollutants. And you can see also from the chemical storage, even you may have emissions from storage tanks. Also, again, volatile organic compounds, VOCs, as an example. And now I want to give you the overview of the different questions in the air emission section. And it looks like this. Oh, sorry. Like this. And so you can see again, we have at level 1, we have several questions. And at level 2, we have only one question. And at level 3, also only one question. So in order to be able to move on to levels 2 and 3, you need to respond to all questions at level 1. And some of them may be, or all of them may be included if you have the applicabilities that control all those questions, but you may also, depending on the type of air emissions that you have, you may only have a few of those questions at level 1. And let's go to the first question. And so this is about the operations and production processes, the Q1 and Q2, the emission tracking. And here, I just want to give you an information about what changes that have been made, because in the air emission section, actually quite a lot has changed. There have been difficulties in completing the air emission section previously, because it was very unclear what are operations emissions and what are production processes emissions. And now SAC has sought to differentiate this clearer, to make this clearer. So there are some updated questions. The questions to report all air emissions from operations and production processes have been revised. And the reporting on quantity of the air emissions, remember you had to fill out how many grams or kilograms of specific pollutants you had been emitting. This question has been removed for now. It will probably be reinserted later again. But this year in the Higg FEM 2020, this question has been removed. And then there is also an updated table to include additional questions on the air pollutant and emission test reports for question 1 and question 2. So those are some updates. So let's go to the first question about operations emission tracking. And the question is, do you track your emissions from operations? And then you should enter data for all your air emissions. So this question focuses on operations emissions. So if you remember the emissions you have from operations, they are, let's go back here to this. Here we can see the operations equipment. Those are generators, boilers, ovens, air conditioning. So this question number 1 is about all emissions from your operations equipment. And then question number 2 is about your emissions from processes and substances. So let's go back then. So this is question number 1. And then here you should report the source, which emissions you have from this source, if you are tracking, which pollutants you have, any regulations and permits that you have, and also any additional comments that you may have. And there is an inventory table available. You can click on this link here, and then you can download this Excel table for you to complete in order to make an inventory. And similarly to in the other sections, water, waste, energy, and actually also chemicals, it is really helpful if you build an inventory so that you are clear on which different emission source do I have, which pollutants do I have. As we said, the concentration you don't need this year. And then also if you have any control devices in place, etc. So this is really helpful for you to have. And this is also helpful during the verification because we see that there is quite a lot of confusion related to air emissions in general. And then the question number 2 is related to the production processes. So do you track your emissions, your air emissions from productions? And then you should indicate the selected process, which emissions you have, the source title of the emission, the tracking you have, the pollutants, and any regulations or permits that you have. So very similar to question number 1. And then it is also suggested that you have an inventory, as I just mentioned, and then that any records or tests that you have made, estimations detailing how the quantity of the emissions were calculated. So that is also important. Obviously, as I said, that question has been removed regarding the quantity of the actual pollutants. And then we have for the question number 2, the production processes and how to calculate and estimate the emissions here. So quite often regarding the production processes, you may need to estimate the emissions you have. And how can you do that? Well, there are different methods for that. So let me go through them. The first one is the inventory based, and this is meant potential to emit, PTE. And by the way, this information and in all its detail is included also into the How to Higg. So this is additional guidance that SAC has provided to us now for the Higg FEM 2020. So for this PTE, for this inventory-based calculation, you have your non-point source emissions. They may require a different methodology to determine the amount of pollutants emitted. So note that specific regulatory calculation reporting methodology may be applicable for fugitive sources. So a potential to emit looks at inventories for all air emissions, including energy generation and process chemistry, to establish the maximum amount that could be emitted from the facility. For example, if you have 1 ton of a specific chemical that was purchased, then 1 ton of that chemical could potentially be emitted to the air. So let's say it's an organic solvent, for example, that actually also emits to air. Of course, there are lots of chemicals that would never end up in the air emissions. But and this is generally a very conservative assumption and gives the maximum potential of emissions from a site. So basically, you then assume that what goes in goes out. So the exact volume of the solvent coming into the factory also goes out as an air emission. So this is, as you can understand, this is a very conservative approach, because of course more than that it can never be, but probably it's less than that. And then the next one is the inventory based, which is potential to emit plus a mass balance and or abatement reduction then. So in this case, you have a PTE analysis as in step 1, and then mass balance and or abatement assumptions may be added. So you have the 1 ton of the solvent that was purchased, but you know that 0.25 tons went to solvent recovery. And then we could assume a maximum of 0.75 tons would be emitted to air. So 1 ton minus 0.25 equals 0.75%, or 0.75 tons. And then let's say you have a thermal oxidizer that also reduces the amount by with a 90% efficiency. So basically of the 0.75 tons you have, you are removing 90%, which means that you then have only 0.05 tons that would be emitted to air. So this same technique can be applied for many different uses of mass balance, including reuse, even wastewater and waste types as well. But now we are talking about air emissions, of course. And then the third approach you can use is to use an emissions factor-based approach. And this means this represents a standard rates of emissions giving a certain process. For example, a process using a recipe of 1 kilogram of a chemical may be tested to show that only 0.05 kilogram is released to air each time that recipe is run. If that's the case, then for every 1 kilogram of chemical used on that process step and on that specific tool, 0.05 kilogram can be multiplied to get the total emissions. These types of testing may be done on-site or off-site by a third party. And please note also that the general recipe and tool must be the same or similar enough to generate the same emissions for this factor to be used. So sometimes for a given facility, hundreds or even thousands of emissions factors are needed to represent their operations, and all testing and documentation must be available to utilize this method. So this is helpful if you have the same process running several times year by year, and you have once done a measurement and you know that in this case, for example, of the 1 kilogram of the VOC that I'm using, for example, only 0.05 kilogram goes out as in the air emissions. And so those are 3 different approaches that you can use to actually to estimate your air emissions without having to do measurements every time. And then we have also for this question, we have one calculation example for you, just to show you how this could work when you want to know which potential emissions you have. So we have, for example, in this case, a spot cleaner, and the content is 370 gram per liter of VOC, so the volatile organic carbons. And the consumption of the spot cleaner in 2020 was 500 liter. And then in order to know the amount, we need to multiply 500 liter times the 370 gram per liter, gives us 185,000 gram, which is 185 kilogram. So the result is then 185 kilogram VOC. So this is also a very, very simple calculation based on the information you have in the data sheet about this VOC, you should know what is the content of VOC, and then if you know how much you use of this, then you can estimate the emitted VOC as well. Okay, and we have also one more example, and this is a bit different because we will be looking at if we already know the concentration. And in this case, we have a factory that operates 300 days in 2020, and the VOC concentration is 0.5 milligram, and the particulate matter is also 0.5 milligram. We know the airflow, and it is 30,000 cubic meter per day. And then we should calculate the facility's particulate matter and VOC's fugitive emissions in the total. And we have then 0.5 for VOC, 0.5 milligram per cubic meter per day, and times 300 days a year times 30,000 cubic meter per day, and then that gives us 4,500,000 milligram per year, which equals 4.5 kilogram in 2020. And you can actually calculate this the other way around as well. If you would like to know the concentration you might have in a room where you are using VOCs or PM. So you can use this formula then in the reversed order in order to calculate the concentrations, if that is what you would like to do. So those were just two calculation examples, and you see this is just engineering, a very simple engineering approach to do these calculations. All right, so this question was 1 and 2. And now let's move on to question number 3 and refrigerants. And the question here is, did your facility add additional refrigerants to any existing equipment during this reporting year? And why do we have this question here? Well, because we want to know that we don't lose refrigerants anywhere. And so obviously, if you have to add refrigerants to any device, then you know that you have a leak somewhere and you need to fix that. So if you respond yes to this question, you will be asked which refrigerants, and you will be adding them one by one. Then the quantity of the refrigerant added, the unit of measure, the tracking method, and also your plan for fixing the leak. So this is information that you then would need to give for each and every refrigerant that you have been adding. And then there is here additional guidance regarding the data management. And you will remember this is very similar guidance now that we have already heard about in the energy, water, and in the energy and water sections. So please review the source data against the aggregated totals to ensure that it is accurate. Please also ensure that the most recent and updated versions of data tracking spreadsheets are being used and that all calculations and formulas are correct. Please ensure that the proper units are reported and verify any unit conversions from source data to reported data, and review any assumption or estimation methodology to ensure accuracy. So the data management in the Higg FEM is so important, and there is a lot of additional guidance now in the Higg FEM 2020 related to the data management. And you should not report data that is not accurate. You should not report estimated data if it's not supported by verifiable and reasonable accurate estimation. It is allowed to do estimations, but you should be able to explain how you have done that estimation and which calculations you have done. And as a verifier, we have also additional guidance here. We should check the initial data collection processes and data sources, the process and tools used to aggregate the data. And of course, if there are any inconsistencies or errors, we should report that as well and make a comment correspondingly. So this was the question about refrigerants, and now let's go to the control devices questions. And now again, we need to differentiate between operations and production processes. And now this question 4 is about the control devices you have in your operations. So for boilers and the other operational equipment. The question here is, does your facility have control devices or abatement processes for on-site point source air emissions? And if yes, select all sources of emissions that have abatement processes. And you should indicate the source, and that is actually pre-populated, and then the control device, abatement process, the frequency of the monitoring, and then also here you see down here in the small font the definition of point source emissions. So this is airflow, which is controlled in some way and released into the atmosphere from a single source, such as stack. So boilers, for example. And then the next question, number 5, is the same question, but now for production processes. Does your facility have control devices or abatement processes for on-site fugitive or non-point source air emissions? And if yes, select all fugitive non-point sources of air emissions that have control devices or abatement processes. And we have the similar questions here again: the source, the control devices, abatement process, and the frequency of monitoring. And here we have then the definition of non-point source or fugitive emissions. And related to those two questions, just a few examples of control devices that you may have. So for example, you may have a dust collector, you may have a bag filter, wet scrubbers, you may have a fume hood for indoor air quality or solvent recovery, or perhaps a local exhaust ventilation of some sort. And here you can see a bag filter, a dust collector. It may be a bag filter actually, and how that would work. So you have from the manufacturing process, and you have the collector, you have a fan, and you have a stack, and it goes out as an emission here. And in this case, this is a point source emission, so an on-site air emission. And then question number 6, this is about, and now we are already at level 2, so all the previous questions, question 1 to question 5, they were at level 1. And now we are at level 2 with the question 6, managing emissions beyond permit. And the question is, has your facility gone beyond permit requirements to achieve a higher level of air performance in nitrogen oxides, sulfur oxides, and particulate matters? And here you may either have made a change of boiler, perhaps a change of your fuel, so that you have better emission values. But it may also be that you have not done a specific change. Perhaps you were already using a much better fuel. And then, of course, you should have a look at this question as well. So even if there was no specific action, but perhaps from the beginning, you had a very good source of energy. And then if we look here into this table, you should, if you have say yes to this question, you will then get a follow-up question, which is which level did you reach? And you can see here level 1, level 2, or level 3. The level 3 is the very best one. And then you can see the different values for particulate matters, SO2 and NOx, for a small boiler, for example, medium boiler and a large boiler. And let's say we have a small boiler. Wait a second, I think I have an example later on. But anyway, how it works is that you check your values. So if you have done measurements, you would know which concentrations do I have in my outlet, in my air emissions. And then you take those values and you identify where you are. So for example, with particulate matters, perhaps you are at 50 here at level 3, or lower than 50 then. With SO2, let's say you are here at level 2. And with NOx, you are now at level 1. in that case, you have only reached level 1. So you need to take the worst level, so to say, that you have reached, because the others may be much better, but with NOx, you have only reached level 1. So then your response here would be that you have reached level 1. And then different ways of achieving higher level of air performance is to have a cleaner energy resource. So perhaps using natural gas instead of oil, for example. Of course, using renewable energy, to have a different air pollution control systems, and then management, improving the efficiency of the conversion of fuel to electricity. So having a better incineration process, for example. And then you could also use, if you are using coal with a high content of sulfur, you may move over and use a coal that has a less concentration, a smaller concentration of sulfur. And so those are just a few examples of what you can do. You can also, for SO2 control, you can use a flue gas desulfurization, a dry or a wet scrubbing. For NOx, you can use, for example, a catalytic filter. For particulate emissions, you can use an electrostatic precipitator, fabric filters like a bag filter, for example, cyclones, multicyclones, and there are also wet scrubbers that you can be using for particulate emissions. So those are just a few examples of the different control systems or devices that you can install in order to improve your air emission concentrations. And here now we have one example. The facility's emission results are particulate matter 75, which means that they are in between here level 2 and level 3, so they have reached level 2. SO2, 1200 milligram. This means that they have actually reached level 1. They haven't reached level 2 really. And NOx 250, that means that they have reached level 2, but they haven't reached level 3. And then in this case, the response is then that they have reached level 1, because they are actually still, they are not at this level. They have a higher level than 1000 for SO2, which means that they then fall back with their entire emissions to level 1, the foundational level. So that's how it goes. You always have to take basically the lowest level that you get. So if one of your emissions are at level 1, then you have level 1. If one of your emissions are at level 2, but all the others at level 3, then you are at level 2. And now the last question here, the question number 7, is about modernized equipment. Do you have a process for implementing modernized equipment to reduce or eliminate air emissions and indoor quality issues at your facility? So the previous question was if you have made any improvements. Let us just go to that question so we can see it here. Yes. So this question number 6 was, have you gone beyond permit requirements? And now question 7 is actually building on that by asking if you have a system or a process for implementing modernized equipment. So this is an ongoing process that you have to continuously check and improve and implement modernized equipment. And here the intent for the facility is to be able to share or demonstrate advanced practices to control air pollutants. And the suggested upload is the documentation of plans and processes for equipment upgrades or documentation also of recent upgrades. And those recent upgrades must be from the reporting year. So if you have made upgrades, for example, in 2019 or 2018 or even earlier, you cannot list them here. Only upgrades that you did in 2020. And then, of course, your process for moving forward into the future and making sure that you can implement modernized equipment. So that is that. And here are some examples. Replacing the equipment. The examples we looked at previously, substituting, for example, ODS with more environmentally friendly refrigerants, cleaner fuel, modifying existing equipment, optimizing abatement equipment, reduce and generally reduce emissions. So this was actually all the questions in the air emission section. And I hope that you find the air emission section now a bit clearer related to the operations emissions and the production process emissions. And let us go and also have a look online. So we are now here in the air emission section. And remember, we have the applicability questions first. So we are asked which operations equipment we have. So again, operations equipment related to operations emissions. Do we have a boiler? We have responded no. A generator, engines, no. Ovens, no. Heating and ventilation, refrigerant, air conditioning, other sources of known air emissions, other sources of volatile organic compounds, yarn spinning, finishes, etc. But I will actually go up here again and select also that we have boilers, a small boiler, and that we have also generators. So we see a lot of good examples down here. And then the processes and also, so this is also clear now. You can see here the questions. First, the question was about operations equipment, and now we have the question about the processes that we have on site. And so let's take a few, let's take dyeing and printing as well, so that we have a few processes here. And we have spot cleaners as well. And does your factory monitor air emissions? And we respond yes here. And now, do you track your air emissions from operations? And now everything we have responded regarding the applicability questions will be populated here into this table. So you can see we now have a stack, vent, air conditioning listed here. And then the question is, for everyone, you need to respond now. Are there emissions from this source? Yes or no? Do you track emissions from this source? Yes or no? And then what equipment is this emission linked to? This is actually also a new additional question in this table. And it's actually quite helpful because then you need to understand what is it, which operation equipment actually goes out into the stack. And in your case, now we have said that we had a boiler. So for example, we would write here the boiler. And then you should also select your pollutants. And you see here we're speaking about particulate matter, nitrogen oxides, sulfur oxides, but you have a lot of other pollutants that you can list here as well. And then the next is this pollutant regulated by a government agency? Yes or no? If the pollutant is regulated by a permit, is it in compliance with the permit? And you should respond then yes or no. And then if your facility is out of compliance, you should upload an action plan. And also, if you have one, an emission test report. So there are quite a lot of additional questions that you get here related to this question here. So this was the operations emissions. And now question 2, we have our productions emissions. And here, similar, we had selected printing, dyeing, spot cleaners, and we get the same questions here as previously. So this is now very clearly differentiated. And then we have the question number 3 about additional refrigerants. If I say no here, that I don't add any additional refrigerants, then I don't get a follow-up question. I can go directly to question number 4. If I respond yes, then my next question is, do you track refrigerant use emissions? And I say yes here, and then I should list all of them. So in this case, I have selected R20, 5 kilograms, it was measured. And yeah, here I have a plan. This is in another language, but my plan to fix the leak, that is important that you add that. And then the question is, do you want to report another added refrigerant? And you can go on as long as you want. If you have 10 different refrigerants that you have added, you should be adding all of them. In this case, we only have one here added. And then the next question is, does your facility have control devices or abatement processes for on-site point source air emissions? And we say no, no here, and then for air conditioning, yes, for example, and you can then complete this table. There are not so many questions here. What control device, what was the frequency of monitoring, and any additional comments. And then the same question, but now for on-site fugitive non-point source air emissions. We had already indicated that we have printing, dyeing, and spot cleaners, so we get that table pre-populated. So always in those tables, you always get it pre-populated depending on your responses to the applicability questions. And now we can go on to level 2. In this case, we have said that we have reached aspirational, for example. And yeah, and then the last question, do you have a process for implementing modernized equipment to reduce or eliminate air emissions and indoor air quality issues at your facility? So that was the demo, and let me now go back to the presentation. And we have come, we have come to our question time. So let me have a look. I believe we have questions here. What is the difference for this section from greenhouse gas in energy section? Do this only for fugitive emissions? Yes, so the greenhouse gas question in the energy section is only about the greenhouse gas emissions that you have. And so, for example, the carbon dioxide that you have, most of it will probably be due to carbon dioxide, but you may have other as well that then contribute to the carbon dioxide equivalents that you have due to the different energy sources that you are using. If you have had a leakage of refrigerants, they will automatically also be added to your greenhouse gas calculation, to your carbon dioxide automatic calculation that is made. So that is the difference. And here we are talking about all other air emissions as well, not only greenhouse gas emissions. So they are not specifically asked for here in this section. All right. Is there any testing frequency for air emission? Yes, it may be that you have through your local permit that it is specified how often you need to test and measure your air emissions. So you need to check that. But SAC and Higg FEM does not specify that. Yes. We are using detergents to remove statins. Is it covered under spot cleaners? Yes, but spot cleaners here are actually meant to be spot cleaners that are using VOCs, that are using volatile organic carbons. If you are using a detergent, probably this is only like a soap, simple soap. So it does probably not have any VOCs included. So the spot cleaners we are looking for here, those are the ones that use VOC. I have a third party that does the air emission tests on my site. Do I still need to calculate the emissions? No. If you have a measurement, then that's even better. Where can we find the VOC amount of a chemical? You should be able to find it in some part of the product information, and usually it should also be included in the SDS, and otherwise you should reach out to the manufacturer. If replacing a lamp to LED or motor to a servo motor. Is this included as modernized equipment? No, this is not included as a modernized equipment because this will not change your air emission. This is good for your energy savings and therefore also for your greenhouse gas emission savings, but it doesn't influence your air emissions. Yes, when I choose boiler, it will have, I will receive stack and vent in question 1. I think we have the air emission measure result for stack. What is the vent? Yes, it may be that you have 2 different outlets of your air emission, so that could then be the stack and the vent. If you only have 1 stack, then you can say that in the vent that you don't have any air emissions there. So you respond no to that question in the table, and you then only have your stack emissions that you have measured then apparently. Yeah, it is a bit confusing with the stack and vent. Is there any way to know the airflow rate without an airflow meter? Yes, it may be if you have a ventilator installed and that ventilator has a certain airflow, a standard airflow at full rate, for example, then you can use that value as an estimation. In which question we have to calculate and upload the quantity of emission? Is this only for question 1? No, so the uploading of the result of the quantity of the emissions has been removed. For now, it may be reinserted later, but you need to know which pollutants you have, and you also need to know if you are in compliance. So then for that, you then would need to have your calculations in any way, even if you don't add the actual specific quantities. Yeah. Some chemical suppliers of ours, they are not following the GHS, the Global Harmonized Standard, with the SDS, for example. So we are not getting the required information from the chemical SDS, any solution for this. This is a problem, of course, and you should try to push your suppliers to add the information you need. There is no other solution. Or what you can do, if you know that a certain chemical product you are buying from a chemical supplier, that there are other chemical suppliers that supply this chemical as well, then and it is identical, for example, then you can go and see if you can find the safety data sheets for this other chemical supplier. So that is what I would be doing. But I would actually also try to push the suppliers to make sure that they harmonize their SDS with the GHS. Using diesel as a fuel for energy, how can facility improve air emission? Yes, it depends what type of operation equipment you have. If you have a boiler that is actually only that you can only use with diesel, then you might need to refurbish that boiler to be able to use perhaps natural gas or something else. So it really depends on the specific equipment you have. So you should speak here to the manufacturer of that equipment and ask them which better energy sources you could be using with their particular device. Yes, I think those are the questions I can respond to right now. So thanks a lot for those questions. If there was any question I missed, I will make sure that we respond to that in a written form. And with that, I would like to continue and just give you some more information about our company. So this slide shows you an overview of all our services. We work also with a lot of brands and manufacturing partners to develop materiality assessment, risk assessments, but also sustainability strategies, long-term sustainability strategies, and we help also with the implementation of those strategies. We work a lot also with the brand and retail module, and furthermore we develop always business cases when we develop strategies together with our clients, and we also produce sustainability reports, sometimes according to the GRI, the Global Reporting Initiative. Furthermore, we work on materials and products. We support brands with guidance related to which materials that are more sustainable, how to build, for example, a product module, how to build a product label. And then we have the third area, supply chain and facilities, and this is what some of you are about, where we are managing the Higg FEM, the SSAP. We do verification, we do consulting and training related to these areas as well. And but we also support factories in mapping their supply chain and understanding their risks and opportunities in their supply chain. And furthermore, we are actually also BPI consultants. And then, of course, we do a lot of trainings and workshops as well. You can book time with us if you wish. You can go to our booking page and there set up a specific appointment with me, or you can also contact us directly, and here you can see some of our contact details in different countries as well, depending on where you are based. So please feel free to reach out to us if you have any questions or if we can support you in any way. And then also regarding our webinars, we have already held several of them. There are 2 more to go. The waste section we will have tomorrow, and then on Thursday we will have the chemical management section. So welcome to join us also tomorrow and the day after tomorrow. And then about our company, here an overview of some of our colleagues. Actually, we are growing so fast, so we haven't been managing to add everyone into this slide yet. And here you have our general contact details, our YouTube channel, LinkedIn, and our newsletter if you would like to sign up to our newsletter as well. And with that, I would like to thank you so much for joining. There is a survey immediately after you leave this webinar. If you could please complete that survey, that would be really helpful for us. And I wish you a nice rest of your day and a good evening, and see you hopefully tomorrow. Bye-bye.